How to drill a hole through hardened steel.
Now that we know that it's possible, how about if I show you how I did this, step by step, and explain each process. And by the way, this only cost me $3 to drill this hole. And if you're wondering, this technique also works for drilling out broken taps. Cutting tool material.
Before we get started, let's take a moment to talk about cutting tool materials. You wouldn't take a piece of wood and try and cut another piece of wood, right? So what you do is take something harder than wood to cut wood. So let's take a look at our range. So this is high-speed steel, good quality, made in the US. Then they add cobalt to it, which would be your next grade up. And this is a cobalt drill bit. So let's take a look here. So this cutting insert here is stellite, which is basically high-speed steel. Then we go to carbide. Then we go to ceramic. And unfortunately, I don't have one to show you. This guy here would be CBN, which would be cubic boron nitride. And then after that would be carbide or diamond, which is as hard as you're going to get. We've already established that high-speed steel won't cut high-speed steel. Hardened steel won't cut hardened steel, even if we add cobalt to it. So that as we move up, we're talking carbide now. So we have a solid carbide drill. And will it drill through here? Yes, it absolutely will. But the problem is carbide is very, very hard, but it's also not flexible at all. So what happens is the cutting tips will break easily if you don't have a rigid setup. So what's our compromise? We are going to take masonry bits or concrete bits that have a carbide tip on the end. So what that does, it allows this mild steel shaft to flex while the rigid tip or the hardened tip stays strong on the end. So now I'm going to show you how to sharpen this to be able to cut through here. And this guy here is a negative angle, okay? The cutting angle at the front should be this way to be positive, this way to be neutral, and then this way negative. So we're negative. So these two are basically the same, but it's easier to see this because it's bigger. This guy here is neutral because the cutting angle is straight on this one. This guy here is a positive cutting angle here. So what we want to do is make this guy here look like this guy. In this case, very hardened steel. So what I'm going to do is I'm going to have my back angle here. Then I'm going to neutral it out, and then I'm going to hollow a little bit of this out here. So it looks almost like this drill here. Okay, where it has that negative or positive angle that goes underneath. So that's what I'm going to try and do with this guy.
Now it's time to sharpen the drill.
Okay, so what I'm going to be doing on this wheel, and it might be hard to see, is, oh, there we go. I'm going to be getting rid of all of the junk on the front. I could do that with the carbide wheel, or sorry, the diamond wheel, but the problem is this stuff clogs the diamond wheel very, very fast. Okay, so what I did there is it only removed the brazing on the front, cleared off the junk basically. So I'm going to clear this side out, and I'm going to clear this side out on all four of the bits.
Now let's switch from the regular wheel to the diamond wheel.
Okay, so now I'm going to try and sharpen this guy. This is an actual diamond wheel. We'll talk about this in a moment.
I have reduced the volume slightly and the background noise because it's a little hard on the ears. So what I'm doing now is I'm slightly putting a positive cutting angle on the front lip of this cutting edge using the side of the wheel. This is a very delicate operation because one little slip, because this piece is so small, it's very easy to make a mistake. and then I'm repeating the same on the opposite side to get both cutting lips the same length. The wheel got a little bit dull, so I'm dressing, and I'll explain that later on in the video. In this part of the video, I sped it up by 8 times, just to show you the technique that I used. Before and after. This is a before and after, just to show how small these bits actually are. The smaller they are, the more difficult they are to actually grind. So the before and after. Additional information. Okay, let's talk for a moment about what we just saw. First of all, up against the diamond wheel, you see me push this little cube. This little cube is a dressing stick for a diamond wheel. Also looks like this as well. Okay, so that dressed the diamond wheel. With the diamond wheel dressed, it cuts carbide like a knife through butter. Also, what you didn't see is this guy. I was wearing safety glasses, and I had this light up helmet thing on, and I put different lenses in. The different lenses are different strengths. So let's talk about options for the diamond wheel. So take a look here. I could turn around, and I'm not endorsing this at all because obviously I use the diamond wheel. Well, here is a diamond cutting blade. You can put this on your grinder, put your grinder in a vise, which I'm not recommending doing, and then turn it on, and you can actually sharpen the bits with this. You want to use this style instead of this style because this is a segmented blade and it'll go chop, 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 chop. When this is spinning around, you don't want to cut yourself. Also, you have this style as well. You can put this style, which is a little bit nicer, inside of your table saw. And you turn around and you go, well, Ray, how much money did you actually spend? I spent $3 on this one, and I highly doubt I spent $5 on this guy. So that's another alternative instead of the diamond wheel. Now you say, well, Ray, that diamond wheel looks expensive. I paid $5 for that diamond wheel from someone who didn't know what it was. Okay, now let's watch the full drill video. Do you see how the chips are starting to come off? And you can see the small chips forming? That's exactly what you want to see. Back from slow motion. Okay, the slow motion thing didn't work. I tried. Keep in mind, this tool bit is only about 200 thou in diameter. Right about now is when the first tool bit breaks. You didn't think that I was going to be able to drill this whole thing with one bit, did you? This is what the broken tool bit looks like. I have replaced the broken bit. This is what it sounds like when you re-enter the hole. Okay, I've lowered the volume and I've sped the video up by 8 times just so that you can see it break through. But there's a little bit more drama coming. And right about here is when I realized that the second tool bit has broken. Time to change. Nice and new. In you go. So I went through a total of 2 drill bits, broken, and the third one wasn't very good at the end anyways. So basically, I went through 3 drill bits. They cost me $1 each. And here's the breakthrough. If you have any questions or comments, don't hesitate to put them in the comments section below. We'd love to have you as part of our community. If you enjoyed this video, please consider liking and subscribing to our channel. Thank you, and have a good night.